So what we're going to do now is to create biconditional statements and evaluate their truth values, as well as to create Venn diagrams. So if you're given these two simple sentences, the first one, P being ABC has a right angle, and Q being ABC is a right triangle, write if P then Q in words and state its truth value. If triangle ABC has a right angle, then triangle ABC is a right triangle. Well, the truth value of this would be true. If the triangle has a right angle, it must be a right triangle. Well, what happens when P and Q are reversed? Symbolically, we're looking for the converse, which would be if Q, then P, right? And this is the converse. Just said that. When we join a conditional and its converse with the word and, this new statement is called a biconditional. Okay. So basically then a biconditional happens to be the conjunction of a conditional and its converse. So basically what we are saying is this. Symbolically, the biconditional is a double arrow, P double arrow Q. It's simplified. Oh, that is a mistake right there. I am sorry. The symbolic form, let's go back up for a second, is actually going to be the two conjunctions. So it's going to be this. If P, then Q, and if Q, then P. So that's the symbolic form. It's the conjunction of a conditional and its converse. If we simplify it, that's where we get the double arrow, the biconditional. And then the way that you would read this would be P if and only if Q. Let's talk about why that this biconditional is the way that it is, though. So if we go to this next page, write the biconditional joining P and Q. So we know that the P statement is going to come first, which says triangle ABC is equilateral if and only if triangle ABC has three equal sides. Well, if you think about that, we can take each of the two different, the conditional and its converse, and determine whether the biconditional is true or false. So if we talk about then if P then Q, and we say, well, ABC is equilateral if ABC is equilateral, then it has three equal sides. We know that's true. So if P then Q is true, the converse, if Q then P, is that true? Let me fix this a little bit better. Is the converse true? If Q, here we go, then P. Well, then that says if ABC triangle has three equal sides, then it is equilateral. And that is true as well. Well, the conditional, or the conjunction, excuse me, of the conditional and its converse, true and true, is in fact true. So what happens then here is ABC is equilateral if and only if ABC has three equal sides is true, because both the conditional and its converse are true. Let's try another one. ABCD is a rectangle, ABCD is a square. So in words, this is going to say ABCD is a rectangle if and only if ABCD is a square. Well, how are we going to determine that truth value? And that's where we've got to take the conditional and its converse and decide from here. So we know that if we take the conditional, if P then Q, ABCD is a rectangle, or excuse me, if ABCD is a rectangle, then ABCD is a square. We know that that happens to be false. We talked about this, I believe, the other day, because for a rectangle to be a square, all four sides must be congruent, and that's not the case. Okay? But then if we take the converse, if Q then P, and we talk about this one, and we say, well, if ABCD is a square, then ABCD is a rectangle, we know that is true. And remember, the biconditional is the conjunction of the conditional and its converse. If I have a false and a true, and I go back to the scenario about if I clean my room and I do the dishes, then I can go out. Well, it turns out that I'm not leaving the house. So the truth value of this happens to be false. And then we get into the scenario. Basically, the way to remember the truth table and the scenario for the biconditional is to think about the rules for multiplication. Think about when you multiply two integers together. If the integers are positive, the integers are negative if you have one of each. So your truth table, fill it out. TTTF, FT, FF. And then what happens is if I've got two of the same signs, in other words, P, if and only if Q, true to true is true because a positive times a positive is a positive. If I had a positive times a negative, it'd be a negative or false. A negative times a positive would also be false, and two negatives would be true. So then where we're here is if a biconditional is true, when the hypothesis and the conclusion have the same truth values. In other words, in order to be true, both statements must both be true or false. Must be both true or both false. All right, so there we go for your biconditional. All that's left to do is the Venn diagrams, and these are graphic organizers that contain two or more overlapping circles. And then we've got a group of 100 students, 36 take French, 52 take German, and 4 take both French and German. Determine the total number of students in the group that are not enrolled in either language course and show how you arrived. That means show all the basic math that you're dealing with. I know most of you will do it mentally, but I still want to see the work. So if I have my overlapping circles, I've got French over here, German over here, and I kind of think about this being my universal set, all in this big old box. I want to start from the innermost or the overlapping kids, the courses that the kids take. So I know that 4 take both French and German, and I know that 36 students take French, but I've already talked about 4 being in French already. So then I would have to do 36 minus 4, and I would know that 32 take French only. There's my total of 36. For the German guys, I know that 4 are already enrolled. If I subtract out the 4 that are enrolled in both, I end up with 48. So 48 are here. And then I'd say, okay, well, I've got 32 plus 4 plus 48. Students already taking a language. That happens to be 84 kids. I know that I'm dealing with 100 to begin with. So if I take 100 and I subtract that by 84, there's 16 students. I'll put this on the outside. 16 students not enrolled in either course. All right, so all the math around it, as simple as it might be, addition and subtraction, you should definitely show it. All right, that's it. So you guys should be good to go.